Good morning, students. Today we are going to discuss the third part of method of undetermined coefficients as a solution of higher order differential equation. It is a component of complete solution as particular integral. We have seen already first part and second part. The first part was without repetition of elements into differential basis and complementary function. The second part was with repetition of elementary complementary functions element and differential basis. In this third part, I would like to cover the combination of Rx as addition of two functions and multiplication of two functions. Like, what will happen if your Rx is, for example, say e raised to x plus sin x? How to define differential basis? And we'll also see what will happen if right hand side is multiplication of two functions. Like, for example, if it is say x square into e raised to x, how to find the differential basis? And I will try to cover the complicated cases like combination of function and repetition of elements also. Let us begin. Okay, so as usual, I am considering second order differential equation y double dash plus c1y dash plus c2y equal to rx. Then I am taking differential operator capital D as dy dx, and that will turn my equation into this form d square y plus c1 dy plus c2y equal to rx. And then separating this equation for y and combination of d will result into operator form, which is f of dy equal to rx. Once we have this form, to find particular integral, we can consider three main methods: direct method, method of undetermined coefficient, and method of variation of parameter. Direct method, for this we have separate videos individually for all five combinations. Method of undetermined coefficient, in this we have three videos and first and second parts are already covered. Today we are going to discuss this third part. And last method is method of variation of parameter, which I will cover in the upcoming videos. So let us focus on method of undetermined coefficients, where we are going to see the random combinations of Rx. Okay, the first possibility is, suppose we have addition of two functions like this. How to find particular integral using method of undetermined coefficients? So equation is y double dash plus 2y dash plus 4y equal to 2x square plus 3e raised to minus x. Converting it into operator form, my equation will take this particular form: d square plus 2d plus 4 times y equal to 2x square plus 3e raised to minus x. Considering auxiliary equation for complementary function as f of d equal to 0, my answer would be m1 m2 minus 1 plus or minus I root 3, and this gives me that alpha is minus 1 and beta is root 3, and therefore I need to take the third case of complementary function, which was for complex non-repeated roots. So it is c1 e raised to alpha x cos beta x, c2 e raised to alpha x sin beta x, alpha minus 1 beta root 3. Now coming to the main discussion, that how to find particular integral using method of undetermined coefficient. So for that we need to consider the differential basis v of Rx. Now here Rx is 2x square plus 3e raised to minus x. So listen very carefully. Here, first of all, I am taking basis of this part 2x square, Along with this function, take all possible derivatives. So derivative of 2x square is 4x square, sorry 4x, and then 4, then 0. That means to take this function and all its possible derivatives, we require these three components, x square, x, and y. Now, taking second part. In second part, we have this function 3e raised to minus x. What is derivative of this? This 3e raised to minus x minus 3e raised to minus x and so on. And therefore, the variable part is only e raised to minus x. Now, as there is addition in between these two, I am taking union of these two differential bases. If there is subtraction or addition in between two functions, we should take union of differential bases. So it gives me x square, x, 1 and e raised to minus x as a differential basis. Now this is the basis of Rx. Let us check whether there is any repetition of elements of basis with elements of complementary function or not. Now here x square, x1, e raised to minus x, these are basis elements, and e raised to minus x into cos x. See, e raised to minus x is there, but it is multiplied with cos and sine. So this is different function than this e raised to minus x. That means we can assume that this is non-repeated case. Means these two elements, capital B and CF, are linearly independent, and therefore I can consider my my particular integral as this element with arbitrary constants A, B, C, and D with addition. Now I want to figure out what are the values of A, B, C, and D. Now the process is as usual. I am assuming that yp is a solution of equation, and therefore I am finding all possible required derivatives. Now as my equation is of second order, I am taking y dash, y double dash. Okay, and therefore I am taking simple derivative of this with respect to x. After finding all possible derivatives, considering this into the equation y double dash minus 2y dash plus y equal to 2x square plus 3e raised to minus x, which will give me this combination particularly. Now, separating all coefficients of x square, x, constant term and e raised to minus x will give me 1, 2, 3 and 4 equations. Now, on the left hand side we have 4a and on the right hand side we have 2, which gives me value of a is 1 by 2. On the left hand side we have 4a plus 4b, on the right hand side we have 0, that gives me value of b is minus 1 by 2. On the left hand side we have 2a plus 2b plus 4c, on the right hand side it is 0, so value of c is 0. Finally, 3d is equal to 3, so d equal to 1. Now taking all these constants into my value of yp will give me final answer 1 half x square minus 1 half x plus e raised to minus x. Combining it with complementary function will give me the general solution as this part. So this is how we can find solution of differential equation using method of undetermined coefficient, where right hand side is addition of or subtraction of two functions. Now let us go for the second part. Suppose my differential equation is y double dash minus y equals to x e raised to x. Now I am taking multiplication of two functions, and then the method which I will use for particular integral will be method of undetermined coefficient. So again the operator form is d square minus 1y equal to x e raised to x. For auxiliary equation I am taking f of d equal to 0, and that gives me two real roots 1 and minus 1. So accordingly complementary function is c1 e raised to x plus c2 e raised to minus x. Now coming to the basis. Now here the function on the right hand side is x e raised to x. So focusing first of all on this x, the differential basis for x is x and 1. Differential basis for e raised to x is e raised to x, and as they are in multiplication, I am taking Cartesian product of these two sets. That gives me x e raised to x comma e raised to x. Now let us check whether there is any repetition in between these elements and CF formula. Now see here, it is e raised to x and e raised to minus x. So clearly we can see that e raised to x is over here, and therefore I need to revise my differential basis, and that gives me x square x e raised to x. Remember, the rule to revise differential basis is to multiply all elements with x. So it gives me x square e raised to x, x e raised to x. Now again verify whether there is any repetition in between these elements and elements of CF formula. So now we can see that these two elements are linearly independent with given basis, and therefore now I can assume that this is the final differential basis. So I am taking a x square e raised to x plus b x e raised to x. Now next step is to identify values of a and b. So for that I am taking y, y dash, y double dash. Now here, as we have x square e raised to x and x e raised to x, y dash will be with help of product rule of derivative. Similarly, at the end of this, I am also separating coefficients of x square e raised to x, x e raised to x, and e raised to x. That will make the second derivative comparatively easy. Now, again, I am taking second derivative and separating x square e raised to x, x e raised to x, and e raised to x. Taking all these three y, y dash, y double dash onto the left hand side of differential equation will give me this possible combination. And then by separating coefficients of x square e raised to x, x e raised to x, and e raised to x, and comparing it with the coefficients on the right hand side to give me a minus a equal to 0. This is 0 equal to 0, identical equation. And then 4a equal to 1, which gives me a is 1 by 4. 2a plus 2b equal to 0, which gives me b is minus a, and therefore b is minus 1 by 4. Taking this 2 into particular integral will give me final answer as 1 by 4 x square e raised to x minus 1 by 4 x e raised to x. Joining it with complementary function will give me final answer. Clearly over here you can see that these four functions e raised to x, x e raised to x, x square e raised to x, and x e raised to x over here, they are linearly independent. So this part you can merge with this x e raised to x. I hope this part is clear now, that how to figure out the solution using method of undetermined coefficient in case of repetition, in case of addition of the function on the right hand side, and in case of multiplication on the right hand side.